Okay, thank you, Jonathan. Good day to all of you. I'm Mageswary from School of Educational Study, University Sains, Malaysia. So just for your information, I've been working on integrating green chemistry in secondary schools for almost 15 years, beginning from 2006 when I started to do my PhD on green chemistry, on finding ways to implement or integrate green chemistry on with secondary school students, and also finding ways to train the pre-service teachers, introduce green chemistry as a pedagogical approach to them. So I have produced various publications in this area, but what I found to this point of time is, even though many efforts has been taking place, but one gap that continuously persists is teachers continuously experience various obstacles to implement green chemistry in school. So after talking to the teachers and also my experience of training the pre-service teachers, I got to know that um, we have to train the teachers from the basic. So in educational studies, theories plays an instrumental role in imposing the framework how to integrate any teaching approach. Yeah, it's not only chemistry, green chemistry, any teaching approach to introduce any new teaching approach. Theories plays a very instrumental role. So from this viewpoint, I thought of looking for theories that can be used to ground green chemistry as a pedagogical approach in schools. So one of the theory that suits very well with green chemistry is activity theory. Oh, I can't move my slide. Okay, so activity theory. So what is activity theory? So I will briefly introduce activity theory, and I'll show you some example of how we used activity theory to bring green chemistry into schools. Okay, so activity theory is also known as a cultural historical activity theory chat. Okay, so activity theory views activity as a unit of analysis. Okay, so activity does not happen by itself, but we as a teacher, we need to structure the activities, and it need to happen under certain condition. So for the activity to be effective, it should be assisted by a tool, or instrument or artifacts. So the artifacts here, in the context of green chemistry, we are presenting green chemistry as as the artifact in the activity, and the activity is performed to meet a purpose. So as Vanya mentioned just now, we have been doing green chemistry, but then it is not incorporated into the heart and soul of the students and teachers. I experienced this as well. After 15 years of working in this area, I still find that teachers are doing it, but it is not incorporated into their heart and soul. It is just implemented as another pedagogical approach. It is just used as another way of doing chemistry. But the real intention of green chemistry, I don't think we have success. Myself over here in Malaysia, I don't think I have successfully achieved the real intention of educating the teachers and students on green chemistry. So I was hoping that our research is at a very infantile stage. So what we are doing is trying to introduce the heart and soul of green chemistry to the students by using activity theory, because activity theory informs that there is a strong relationship between the activity that the students conduct with the consciousness. Okay, so let's see what is activity theory. Right. So activity theory originated in Marxist philosophy. It is introduced by Soviet psychologists in beginning of 1920s and 1930s. So how activity theory is different from other activity is that activity theory, it is artifact mediated or object oriented action. So it is not, the behavior is not because of a response to a stimuli, but it is activity is mediated by an artifact, and it is performed to achieve any objective, or it has an intention. Okay, so the artifacts could be any part of human development, or it can be the activities that is conducted to develop their mind, cognition, or physical outcome. So activity theory is also known as a hidden secret in academia. So we were trying to use activity theory to bring green chemistry to the schools and to train the teachers. So the first generation of activity theory, it has 3 elements, and it is proposed by Vygotsky in early 1930s. So it says that subject, which is mainly students, they react with any kind of artifacts. It can be any tool to achieve the objective or the activity. There is a motive for the students to participate in that activity. So that this triangle shows the interrelationship between the subject, the tool, and the object, which is the objective of achieving the purpose of participating in the activity. So this the first generation activity theory is expanded further by Engerstrom in 1999 by including the societal component. So he says that it's not only individual subject, but activity is socially based. So the 3 dimension or 3 elements of activity theory is expanded by having rules, by integrating the community, and by having division of labors. So when the activity is performed by considering all these 7 elements to achieve the objective, collectively the objective can lead to the outcome. So the outcome can be maybe we want to come out with the students are more aware about consequences of using chemicals, not only during the short period of participating in the green chemistry activity, but the changes could be something which is more sustainable. So so the activity theory, the revised version, it has 7 elements, and we consider doing the activity with integrating all these 7 elements. Okay, so what is subjects? Subject here is so we have used the 2nd generation activity theory to bring to implement green chemistry. So subject here in our context, subjects is the students or the individual who will be participating in the study. The object is the objective of their participation, the objective of engaging in the artifacts. The artifacts that we are introducing in this study is the green chemistry experiments, or the artifacts is also known as tools. So the artifacts or the tools that we are introducing in this study is the green chemistry activities and experiments. So subject, the students, they will be handling the artifacts in order to achieve the objective. So the objective is there are various objectives whereby the objectives are separated and presented according to the activities. Okay, so maybe the objective 1 could be coming up with a procedure, or coming up with the objective of the goal of doing the experiment. So later I'll show you one example. Rules is set of principles that the student, or laws the students that they need to abide to. Community can be the teachers, can be the lab. We have lab assistants in our system, whereby the lab assistant will participate with the students in designing and also performing the activity. Division of labor, so each and every community member, the students are assigned to a task. They are assigned to do a work in their group. So this activity is conducted in group because according to Vygotsky, um, um, learning happen in social context. It's not in an individual context, it happens in the social context. So division of labor, it's assigning task to the individual students and also how the community can participate in the learning. So collectively, when the activity is designed by integrating all these 7 elements, it leads to several objectives, and these several objective will be make sense into the overall outcome for the purpose of having the for the purpose of conducting the experiment. So this is a few information that you should know about activity theory. It is a philosophical framework for studying different form of human praxis. So we are going to look into human behavior. So we are using this framework because it's going to look into human behavior from different perspective. And because activity theory adapts Marxist dialectic material view of activity and consciousness. So we are not going to separate participating in the activity and the consciousness. So we are going to say that when the student participate in the activity, they are participating with the full consciousness of the intention of doing the activity. So learning, conscious learning and activity are completely interactive and interdependent. So the participating in the activity and also the consciousness, it works together. It's not separate. So similarly, activity cannot occur without consciousness. So the mind, it is a kind of mindful learning, and usual framework for understanding the totality of human work and praxis that activity is in context. So we are the activity itself sets a context for the students to learn green chemistry. It's students to learn green chemistry. But in actual fact, we are going to teach chemistry concept, but while teaching chemistry concept, we are showing them in how they can learn chemistry in a greener perspective, simultaneously situating the greener perspective into activity which forms a context for them to conduct the lesson. Okay, so basically it is a way of bridging the theory and practice. Currently, we talk a lot about the theoretical perspective of green chemistry, but when it comes to practice, my experience of doing green chemistry for the past 15 years, there is a gap between theory and practice, so they do it for that point of time, but beyond that, I don't think the impact is sustainable for a longer period. So in order to deliver an impact which is more sustainable, we are trying to bridge the theory and practice by using activity theory. So this is some usage of activities theory that we have identified in the literature. So people have used in project work to examine teacher education, studying science teacher reflection. So these are some of the examples. And then some studies have said that activity theory as a framework for designing activity. So this is the work that has actually guided us on how to use activity theory to design green chemistry lesson. Okay, so these are some of the examples that are available in the literature. So maybe if you are interested, you can read further. And specifically on chemistry, activity theory has been also used by this person, when Halswood, he has talked about employing activity theory to increase the relevance of secondary level chemistry. Thomas and McRobbie said that activity theory assisted students to understand and engage in thinking. Activity theory also provided positive learning environment in chemistry, and activity theory promoted students' critical thinking. So to some extent, activity theory has been used in chemistry education, but there's no literature on how activity theory is used in green chemistry. So we have done that, trying to integrate activity theory in green chemistry. So activity theory argues that decontextualized performance produce little or no understanding. So when you decontextualize the learning does not takes place. We have to contextualize the learning. So one way of contextualize the learning is by using activity theory. So since green chemistry has the connectivity between subject matter and students' everyday learning, and also green chemistry provide a relevant context to situate sustainability within teaching of chemistry. So we thought that activity theory would be the best approach to contextualize green chemistry while learning chemistry, because we cannot in Malaysian system. In Malaysia, the system is very much of a centralized system. That means teachers do not have the authority to change the curriculum or change the syllabus or do any kind of modification. So the teachers need to use the syllabus or guideline provided by the Ministry of Education and perform the teaching. So to introduce green chemistry into a system, a very rigid system, it is impossible. So by situating green chemistry within the activity theory, we were hoping that we would teach the teachers the theoretical foundation. We will provide the teachers with the theoretical foundation so that they can do it in the classroom. So so for this contextualizing green chemistry within activity theory, it in some way responds to the call that learn the principle of green chemistry are best delivered when it is used as a context to teach chemistry. So we by Prescott, so we hold to his view, and then we try to contextualize green chemistry using activity theory. So how we did it? Okay, so I'll show you one example. We have several examples, but in this talk, I will show just one example. So ATGC is activity theory based green chemistry experiments. So the experiments are divided into 4 phases. The first phase is a pre-lab phase, whereby it is conducted 2 days prior to the real lab. Phase 2 is during the activity. Phase 3 is the post-lab after the activity. And phase 4 is the extended post-lab, next day of the activity, whereby we conducted this on the social media platform. The students were given option whether to do it on the WhatsApp platform, and some conducted on the Facebook using Facebook, the phase 4, which is the extended post-lab. So what happened in the phase 1, which is the pre-lab? Okay, so I will show you the experiment on developing an electrochemical series, how the students developed electrochemical series using a simple experiment. So in the phase 1 pre-lab, 2 days prior to the treatment, students were provided with a context or questions that and a guide about the experimental procedures were given to the students. So we have 2 different sheets. One is a lesson plan for the teacher, another one is a student's guide. So in the lesson plan for the teachers, we list out all the steps that the action that teachers should perform, and the students guide for the students, we list out the action that the students need to perform. So for the pre-lab, the students were provided with some questions and also some guidance about the experimental procedures and also a context. So the context that we have chosen is in the pre-lab that were given to the student is that the ring that you bought a couple of weeks ago is already turning your finger green and looks dull. Another ring that you had for years still looks almost new. Why is this? So this is a context that they need to find answer and hypothetical answer prior to the real lab. So we also included questions like, do you think the following reaction would occur? Explain. So they need to find answer and they need to find explanation for the pre-lab context. So in this situation, when we match it with the activity theory, the elements that are involved are subject, tool, and object. So what is the subject? The subject are the students. Then they will be interacting with the community, and also they will be doing some interaction outside the school community. So that are the subjects. And then the tools here is the context that we have provided. So this is the tool or the context that we have provided, where they need to deal with this context to find answer, to hypothesize what could be the possible answer. And then the object would be the object is the answer that they might discuss and produce at the end of their pre-lab session. That means the object is the aim of conducting the pre-lab session. So collectively, there are two levels of activity theory taking place: subject, tool, object, and then also subject, learning community, and object. Okay, so this is at the pre-lab session. Then during the experiment, which is conducted for 60 minutes, so students create the filter paper electrochemical series, whereby they need to cut the filter paper according to this shape, and then they need to label the metals, and also they react the metals with the salt solution, and then they prepare, they come out, then they measure the voltage, and then they come out with a table listing the voltage reading of the metals. Okay, so in this section, what we can see is subject, division, label, and object. So the activity is designed in such a way, considering these three elements of activity theory. And simultaneously, not only subject, division, label, and object, subject, rules, and also object. So each level of activity, there is some kind of objective to be achieved. And in order to achieve the objective, there must be involvement of the student, and also they must follow certain rules. And similarly, in order to achieve the objective, the subject must must work according to the task assigned to them in achieving the objective. So collectively, phase one, there is some kind of objective. In the phase two, whereby during the experiment, there is several objectives. And in the phase three, after the experimentation, students are posed with several questions like what I have listed here. They need to find answer, work in a group, discuss with the teacher, and also maybe they can refer to internet resources to find answers. And during this time, there is also some elements of activity theory involved. So object, division of labor, and community. So it's not only they discuss among their colleagues, the friends, the peers, they also can discuss with the outer community who has this knowledge on electrochemical series, and also have knowledge on green chemistry. So
Sorry,
collective.
Sorry, we'll have to wrap up in about one minute, maybe 1.5 minutes, so we can get to the question period. So, hopefully that's okay.
Right. So this is my last slide. So phase four is extended lab. So now they in the extended lab, this group, they discuss the real answer for the pre-lab findings on the WhatsApp group platform, and they finalize whether the answer that they made it, they obtained during the pre-lab is correct, or they need to do some kind of revision to address the answer. So that is the phase 4 of extended post-lab. So even at this point, there is there are several elements of activity theory involved. So basically, we have listed many experiments using activity theory. So these are the list of experiments which we have done based on activity theory. And we found that students' perception about the laboratory learning environment changed, in terms of student cohesiveness, open-endedness, integration, rule clarity, and material environment. Students viewed that there is a stronger cohesiveness in the activity theory-based lesson. They feel they experience more open-endedness and integration. Material environment and rule. In terms of rule clarity, the finding was not so explicit, but other than that, the other 4 dimension, it was very clear. Can see a difference, a significant difference. So so at the end, we found that it is a good platform to deliver green chemistry, but as I said, we are still at the infantil stage. We are working more, and we are also investigating how the heart and mind of the students, green chemistry is incorporated within the heart and mind of students with this activity theory. Thank you.